So, first of all, thank you very, very much for being here at this ungodly hour. I am amazed that you are here, because it was difficult for me also. So I know the feeling. And today we'll be talking about JobRunr. So what is JobRunr? It's an open source library. And I think it's the ultimate library for background job processing in Java, but I'm biased because I created it originally, so don't take my words for it. It's distributed, and it's backed by persistent storage. And of course, it's open and free for commercial use. I was lucky enough to be featured in ThoughtWorks, so they apparently also enjoy using JobRunr, and I never thought that this would happen, because yeah, it all started out as a hobby project, but later more about that. So the agenda for this talk: who am I? Who are you? Then I'll go into the background why I created JobRunr. And then, of course, talk is cheap. Show me the code. We're all developers here, so I'll try to do some live coding. Then we go into the internals of JobRunr. How does it work? I'll talk about JobRunr today and tomorrow, and then there's time for Q&A. And then the eating my own dog food is also the live coding part. Let's see how it goes. So, who am I? I'm a developer, of course, tinkerer. I've got 3 kids. I have been born in the right country because I love beers, and I think that in Belgium we have more types of beers than we do have inhabitants, so that's a great place to live. And then, who are you? I changed it this night to brave, early rising men and women. So. Nice that you're all here. And I was wondering, does anybody already know JobRunr by any chance? 1, 2, 3, 4. I really need to fire my marketing manager, because it's not enough hands. Marketing manager would be me. So, all right, let's dive into it. 3 years ago, I was consulting as a consulting, and they lured me into a new assignment, and they said, yeah, it's a greenfield project we're working on. It's in fintech, and yeah, the goal is to do invoicing to the PEPL network. And notice the small quotes around greenfield projects. So first of all, what is PEPL? PEPL stands for Pan-European Public Procurement Online. And as you all may know, in Brussels, we have the European Parliament and European Commission. And I think that's the reason why these people make so much money. It's because they can come up with all these difficult names for something really easy. Because PEPL is nothing more than e-invoicing and e-procurement standard for Europe. And of course, being fintech and banking, this is all XML documents that are transmitted over the wire, and often the actual invoice is embedded within the XML document. When I joined the project, it was a microservice party, so a lot of RESTful microservices on GCP. It had an asynchronous external API, so the first call where we received the XML document and the invoice saved the actual document to storage, and then we put an event on PubSub for further processing. All the other internal communication was synchronous using RESTful APIs. And the goal was to process millions of documents per day, but yeah, greenfield project, we had some customers, but it wasn't that much. But microservices. When I said it's a greenfield project, they were already building on it for a year, and it was due to go into production 3 months later on. And soon I found out, okay, when one of those RESTful HTTP calls failed, processing was not retried. And the guys didn't have any monitoring yet. Logging was done without any correlation ID in this RESTful architecture or this microservice architecture, and invoices got lost. The messages accumulated on the dead letter queue of PubSub. So I don't know about you, but invoices not being processed, a lot of people were not really happy. So this was the greenfield project I was taught that I would join. This is how I felt after 2 weeks into the project. I considered a small career change, but decided not to do so. So I was thinking, are there any other solutions? And there are, but they're often vendor-specific, cloud-based solutions. And they also often require extra infrastructure, like Apache Kafka, Apache Hadoop, and Spark. They need Hadoop FS, which is easy to set up, but not so easy to maintain in the long run. And there wasn't any open source one-stop shop that is easy to use, and with that I mean really developer-friendly, distributed by default, that uses your existing infrastructure, that includes monitoring, and that has resilience built in. And I believe that we're maybe not all working for Facebook, LinkedIn, Netflix, and process petabytes of data per day. I do believe that we often need to solve complex business processes with a moderate amount of data. Think gigabytes, perhaps terabytes. I also believe that we don't need extra infrastructure just to run some processing or background jobs. Let's keep it simple and stupid and reuse proven technologies like SQL and NoSQL databases. I think that creating and running jobs should be fast and easy. And failing jobs should be retried by default and only bug me if they don't succeed after a while. It should be resilient by default. I also believe that we should have instant insights in how our jobs are doing or how our code is doing. And such a tool should be self-maintaining and be plug and play into our existing code base. And these are the beliefs that I keep for myself whenever I touch or develop something on JobRunner. So with these beliefs, I started to work on JobRunner back in 2020. By the way, that was right before the pandemic. I quit my job, or I stopped the freelancing. I went working for that, for JobRunner full time, and then the whole world got locked down. I then don't dare to say the expression, but I was really scared, and yeah, but yeah. So then I started developing of JobRunner, and I wanted to make it as simple as possible and just use Java 8 lambdas to create a background job. JobRunner is distributed and cluster friendly, and it uses your existing infrastructure. It's embeddable. You just add one dependency to your code and you're set to go. You don't need anything else. It's resilient. It will retry jobs automatically. And it comes out of the box with a free dashboard. So monitoring is included by default. And of course, it integrates with the best, being Spring Boot, Quarkus, and Micronaut. So how does this all look? This is all you need to run a background job. You just say background job or job scheduler.enqueue, and you give it any Java 8 lambda. And JobRunner will make sure that it will get executed. And this is the dashboard I was talking about. Here you can see how many jobs are being processed per 10 seconds. So I think it's now time for some actual live coding. And I always try to share responsibilities in the projects that I do. So let's call it mob programming. And if I fail, then please help me out. To do so, I will create a new project. Let me quickly copy something that I forgot to do yesterday evening. And this will be a simple JFall demo project using Java 17 still. I should update it to 21 really soon. And let's add some dependencies. So I'm going to, by the way, is this readable for everybody? Yes? Okay. We add JobRunr. JobRunr internally uses some JSON, so we can either use Jackson or JSON, and logging. Let's refresh the dependencies and make a new class. And I made a typo. And I deliberately keep it as simple as possible. Of course, everything that I'm doing now will also work out of the box without any configuration in Spring Boot and Quarkus. So the first thing that we need is, of course, JobRunr, and we want to configure it. And for this demo, I will use an in-memory storage provider. If you want to distribute your jobs, this is a bad thing to do, of course, but you can use like Mongo, SQL database, and it's just another implementation of the storage provider. We want to use or enable background jobs processing, so we use the background job server. We also want to show the dashboard. We initialize it, and I want to have the job scheduler available to create some jobs. Then, typically, I don't know about you guys, I often work with Spring Boot or Quarkus or any of the other libraries, other frameworks out there, and we often have some services, for example. So I will create a new test service. Voila. And let me remove this, that it's a little bit more space. So we create the class. And then next we want to, thank you, in the IntelliJ AI is already saw what I did yesterday. So we want to enqueue any job. Let's say test service some method. Of course, this method needs to be created. And we can, of course, pass in variables. Let's make it really simple for now. So that should be that. We need to pass in a variable. And let's already try to run that. Voila, it's up and running. And it already mentions here, hey, the dashboard is running on port 8000 by default. And I think, yeah, the job is also already done. So if we go to the dashboard, and I know that I have too many open tabs, multitasker. Here in the succeeded job, we see the job, and it says, hey, this job has already succeeded. I will automatically delete it in 1 day from now, and you can see the different states it went through. The dashboard offers a lot more. You can have live logging and a progress bar from your code. so that way you know how your job is doing. But that's not the only thing it can do. Let's say that you want to send out a batch of emails this night. Then, of course, we schedule a job instead of enqueuing. So I do instant.now plus some time, so duration of hours 10. And again, I can do test service.some methods. Well, let's call it scheduled. And what I will do also now is add some fake artificial sleep in it. Let's make it sleep for about 15 seconds. And the other thing you see now, hey, sleep, it throws an interrupt exception. Well, I'd like you to embrace exceptions. Just throw them, because JobRunner will retry anyway if something goes wrong. So that helps. Oops. And then done. Voila, let's restart again. Here we go. And what you see, the dashboard has already updated. It now mentions, hey, there is one scheduled job, and it's scheduled 10 hours from now. And there is one job processing. And if I wait long enough, you will see it automatically go to succeeded right here on the dashboard. So yeah, some server-sent events that make this all work. Voila, there it is. But you can do a lot more. Let's say that you want to welcome all your new subscribers each night with an email. Well, we can also schedule a recurrent job with a certain cron. And to make either, who likes writing crons? 1, 2, okay. I personally, myself, I hate it. That's one of the reasons I use ChatGPT to help me write crons, but I made something a little bit easier, so let's run it daily at 9 o'clock. Perhaps I should put 8,20, and then again we can do the same method. And I did something wrong. Oops, and there's voila. I don't know about you guys, but this here, the job details, I don't feel it. It's not that really helpful. Let's make it more readable. And that's why you have the job annotation. And the job annotation allows you to give a name, the amount of retries that you want to do for that job, and optional labels. So let's give it a name, my test service. And I can also use variables in here. So if you want to print this variable inside the job name, that's also possible, but I forgot the syntax. I think it's %0. Let's see. It's the same as a string format normally. Let's have a look. Yeah, so here I now see my test service scheduled. So this, and of course the recurring jobs. Here we see the recurring jobs. It has an ID. By default, JobRunner uses the job signature as an ID. You can specify your own ID if you want. And I highly recommend that. Why is that? Let's say that you later on would like to update it inside your database, then it will override the, it uses the ID to find the existing recurring job. Let's have a look. Did it already restart? Ah, yeah, I've stopped it, so it's the sleep has been interrupted. Come, die. It tries for 10 seconds to finish gracefully, and otherwise, yeah, it just up. So voila, now you see it's my ID, my test service, recurring job. And if a job would fail for any reason, then let's do that. If we go to up here, let's do it here. So, boop. No, this is not what I want. Throw new illegal state exception. Things, I was about to write a dirty word. Things don't always work. And let's restart that. And it's up and running. And what we should see, so it's processing, and then after 15 seconds, it will probably fail, and our dashboard will also mention that, hey, your job failed, and I will retry it. Voila. An exception occurred during the performance of the job, and you see the exact reasons why things are failing. And of course, it's going to retry any minute now. So that's it for the demo. Are there perhaps any questions on this part? No, still early. I understand completely.
I have a question.
Yes.
On the logs, something about the zookeeper.
Yes.
Why is it used?
It's not the official Apache zookeeper. It's just a name that I use as because to do zookeeping. So it's not that you need to install any other dependency. All I did is add this to the POM, the JobRunner, and a Jackson library, and that's all that it needs. All the coordination is done via the database. So the database is the central truth. And of course, it keeps on retrying, and you see the logs happening right here. All right. That being said, let's continue. Okay, thank you for that. And let's do some deep dive. So, how does JobRunr work internally? Well, as you see here, typically you create a job somewhere, for example, on the website where requests come in. And JobRunner's main task is to save that job as fast as possible to the database, and it returns. That way, the website is not blocked. And then you can have 1 to n background job service. During the demo, I had everything in one, of course, because I enabled both the background job server and the dashboard, the job scheduler, which is enabled by default. And these n background job servers, they go to the database and they ask, hey, is there any work to do? And if so, they start processing it. And then the thing I struggled the most with is in Java, there is no way to find out what's actually going on inside a lambda. And after posting on some blog posts, people told me you should have a look into ASM. And ASM is a bytecode reading library. And welcome to bytecode 101. Because what happens internally is that any lambda will be compiled to a synthetic method that you can then also find in your class files. And if you see here, for example, what do? We have background job.enqueue, blub, blub, blub. And what is the actual compiled method from this Java 8 Lambda? Well, it's this method. And what you see isn't that hard. I found during developing JobRunner that bytecode isn't, or the Java bytecode isn't that hard at all. So what it first does, it gets the static Java lang system out field, and this returns a print stream. Then it puts something on the stack, which is the string that we pass in. And then this is the really interesting method. It's the invoke virtual. And the invoke virtual is actually the method that we're interested in. And this is the method that needs to be executed. If we go, for example, with the test service that we did during the demo with all the different variables, it's exactly the same thing almost. So we have some line numbers. What it does, it loads the test service, which is available from, or am I lying? It loads, I think it loads 0 on the stack. Then we get the actual field from the class where we want to run this on. So this is from a test internally in JobRunner. It gets the actual test service field. And this again returns the test service. So it's almost the same as we had during the demo. Then we put some string on the stack. We put 1 on the stack. And we invoke instant now and have the timestamp on the stack. And last but not least, we again have the invoke virtual method in which we are interested in with the complete signature. So bytecode is not that hard, I found out. Oops, and there is this thing here at the bottom. Isn't this dangerous? So a question I rightfully got from Reddit when I posted it originally. Your library may be nice at first glance, but there is so much black magic going on that just should never be relied upon, they said. And I see what he means, but everybody is already using this kind of stuff. Whenever you're using Hibernate, for example, you're using ASM internally to do all of this black magic. Also for Java programs, there are 3 main categories of compatibility. You have source code compatibility, so that way you have, when you type your source code, that your APIs don't break, or your RESTful API, for example, is also source type of compatibility. You have binary compatibility, and this is defined in the Java language specification. And with that, I mean is you can still take any code that was compiled on Java 1 or Java 1.4 and take it, run it on Java 21, it will still work. So the binary or the Java language specification is really hard, and yeah, it doesn't change often. On top of that, Oracle contacted me, and I was really surprised by that. And they asked, hey, we see that you're doing stuff with bytecode. Don't you want to participate in the Oracle quality outreach programming? And of course, I jumped up on this opportunity. And so what does that mean? They notify me, hey, we have released a new early access version of the Java. Can you test it, and please make sure, does JobRunner still work? And if not, yeah, create a bug report. And this is really great because I know if really early on if something may break in a next version, and they get early feedback from libraries like me and the others where whenever something would not work anymore. And on top of that, I really enjoy writing tests. So within JobRunner, there is a test that makes sure that it runs on all these different, and there are even more now, but it's really compiled and run on GTK 8, 11, 14, and so on. So that's make sure that things don't break. So I don't agree with the person that much, but yeah, I still understand the sentiment about it. And that's why with the release of JobRunner 4, I added a new feature, which is called the job request and job request handler. And it's a new way to create jobs using the command handler pattern. So what does that mean? Let's say you want to send an email job. In that case, you just implement the interface job request, and there is one method that you need to define in there, and that is define or return the class that will do the actual processing of your job. This is, in this case, the send email job request handler. And of course, we have records now, so this becomes really short. We just have a record, and we add this method. And the handler, again, just implements a job request handler, and you say what type of request it will process. And then it will ask you to override one method, the public void run method, and in there you do your code, and JobRunner makes sure it is executed correctly. So how does that look? Well, in that case, you have job request scheduler or background job request .enqueue, and then you say you send email request from me to the NLJUG, hey JFAL team. I quickly wanted to share that I had a blast on JFAL. You are a great audience, and I look forward to next year. So this is how you can schedule jobs if you don't want to use the Java 8 Lambda way. So analyzing the Lambda, so we now know what we need to run, and I'm quickly going to check the time to make sure that I don't pass it. I'm still good. And the next thing I do is I convert the Lambda or the job details to JSON. And why JSON? Well, because it's proven. I like it. It's easy. And what is in there? Well, you have the class name, the method name, if there is a static field that you need to get out, and then the job parameters that you passed along. So for the earlier method we had, this is what will be saved inside the JSON. This is the newer version. It's changed a little bit over the years. And how does it look now? Well, there is cacheable, which means JobRunner can really enqueue the jobs really fast. You have, again, the class name, test service. We don't need a static field name. It's null in this case. This is the method that we want to call, and then all the different parameters that you passed along. And what's really important is that the parameters that you pass along should, of course, be serializable with the JSON library that you use. And why JSON? Well, again, for me, it's all about KISS. I really like simple solutions. It's readable, it's debuggable if something goes wrong. It's easy to use for me in the dashboard, and that's all there is to it. So we now have the job in JSON, and we store it then in the database or a NoSQL database. So how does this look? Well, the first thing that we do is we save the actual MDC context from SLF4G also to the job. That way, if you use a correlation ID over a different request, you can also find it inside the job. We run some filters where you can hook into JobRunner to have extra code running whenever a job is created. We save it, and that's it. And we return a job ID. And here is an important part. No, it's not here yet. This is whenever you have a job with the same ID that already exists, then JobRunner will not run it. And the ID is a GUID, so a UUID. And then these are all the different storage providers that JobRunner supports. So Document2B, which is the Mongo from Amazon, Elasticsearch, Mongo itself, Redis, and then all the different SQL databases. Now the job is actually saved inside the database, and then it's time to execute that job. So we check for enqueued jobs. Are there any jobs that can be enqueued? And inside the server, we check how much CPU do we still have available for jobs to run. So let's say you enqueued 1 million jobs, and your hardware can only run 100 jobs at the same time. Well, JobRunner will check your CPU and then see how much threads it can run and ask for that amount of jobs. And these are then enqueued jobs. And for each of these enqueued jobs, we start processing the different jobs. And then here is a really important part. We start job processing, but the first thing we do is we try to save it again to the database. And why is that? That's for optimistic locking. So this way, JobRunner makes sure that your job is executed only once. So it saves it to, if you have a distributed architecture, I have heard about some people who use 30 different background job servers, which are all trying to process work. Well, the first server that can save the job in state processing is the one that will be allowed to process the job. Otherwise, we have a concurrent job modification exception, and it means that the processing already started on another server. The actual job is being processed, so we notify that a thread has been occupied. We update the state to processing. This was the optimistic locking I was talking about right before. And then the actual job is run, and if it succeeds, we update the job to succeeded. If it fails for some reason, well, it can be deleted while we were processing. Yeah, then there's nothing we need to do anymore. The server may have stopped. Well, in that case, we failed the job because somebody asked for the server to stop. The job method cannot be found anymore because your code changed. Then in that case, we cannot execute it anymore. And it's failed for some other reason. That was the reason before in the demo where I just threw exceptions. Yeah, then we update the job state to failed, and we again run the job filters where you can hook in your custom logic. And finally, we say, hey, there is a thread idle again, so we can onboard new work. And running the actual job is a little bit of reflection, not even if you're using, it's always reflection, but if you, for example, use Spring Boot or Quarkus or Micronaut, we will ask for the bean at your IOC container. We then get the method to perform, and we give it all the parameters, and we're done. And I thought this would be perhaps a bottleneck, but the GDK or the runtime got so good in optimizing all of this that this reflection part is not even a problem these days anymore. And last but not least, the job is saved either successfully or failed, like we saw, and we can then follow all along in the dashboard. And if it fails, we see the exception, of course. So these are some internals of JobRunner. And then JobRunner today and JobRunner tomorrow. So how is it used? Well, it's used for medical image web processing, web crawling, order fulfillment, document generation, e-procurement, service desk automations. These are only the use cases that I know. I never thought this would ever happen when I started on it 3 years ago, but it's now downloaded about 200,000 times per month from Maven Central. And in the last 1.5 years, it has about processed 83 billion jobs. How do I know? JobRunner, it's default opt-in, that's also mentioned on the documentation. It sends some anonymous usage statistics, like how many jobs have been run. And that's how I know of this figure. Of course, you can opt out of this. And yeah, I have 3 kids to feed, so how do I do that now? Well, I created JobRunner Pro, and initially the idea would be like, let's hope that my wife and me, we can have an extra dinner date once in a while with JobRunner Pro, but it grew more than I ever expected. And what does JobRunner Pro offer? It offers an extended dashboard where you can search with a lot more features. It also, by default, completely integrates with Spring at transaction support. And it has queues, batches, job training, server tags, a lot more features that allow you to create workflows even. And because I'm really scared about climate change, with the profits I make, we also support team trees. So I think there are now about 3,500 trees planted with JobRunner profits, or revenue. So that's that. And then, if I look ahead to the future, what will still happen? Better GraalVM native support. It works out of the box already in Spring Boot. Quarkus, somebody's contributing it, and Micronaut is still on the to-do list, but the usage of Micronaut is really low, so it's not really, how must I say, a high priority feature for me. I'm currently looking into making JobRunner faster and more efficient, together with a Java champion that really knows about performance. We're working together with the University of Leuven to add machine learning to it, meaning that JobRunner will automatically tune some parameters for you to optimize job throughput. And of course, feature requests from all of you. So then it's time for Q&A. But first, a big shout out also to Started at KBC. They helped me, and Flanders Investment and Trade, because they sponsored my travel arrangements here. And the conclusion of this JobRunner deep dive: only one dependency. You can use a Java 8 Lambda or a job request. It's distributed by default. It comes with a built-in dashboard, and it's resilient thanks to automatic retries. And remember to give feedback. If you enjoy using JobRunner, you would do me a favor with starting the GitHub repo. If you want me to give my kids some food, you can always try and convince your manager. And I would say, enjoy the rest of the conference. Thank you very much. Are there any questions, perhaps? Yes?
Will JobRunner benefit from the new virtual threads in Java?
That's a really good question. I don't think we need a mic. Everybody can hear each other, and I'll repeat the question otherwise. So the question was, will JobRunner benefit from virtual threads? I did a test back in 2020 to change already the threading from the executor service to virtual threads. What I noticed was that memory consumption was lower. But that was it. It's not that it goes faster. And the reason often is that if your jobs is doing something and it's bounded to the work that it's doing. So, but again, that's why I'm working together with the Java champion to see whether we can improve something there. And it's definitely on the roadmap for JobRunner 7 to also support virtual threads out of the box. The difficult thing is, though, that although I would love everybody to upgrade to Java 17, 21, and so on, there are still a lot of companies using Java 8, for example, the medical image company. And for them, it's difficult to switch to a newer version because it requires a whole new FDA process. And that's why companies are not always that fast in upgrading. But good question, looking into it. First idea, maybe less memory. I blogged about it also on the website, on the JobRunner website. Any other questions? Yes?
Can you tell something about upgrading when you make changes for your software?
Yeah. So, good question. How to upgrade and to have continuous delivery, continuous deployment. Well, what JobRunner does, of course, is save the JSON inside your database. The moment that you change the method or add a parameter or remove a parameter, it will not work anymore. And then that's really difficult as an open source developer. Where do you put which feature where? In JobRunner Pro, you have 2 things that you can use. It's a unit test that will query the dashboard to see whether your current code still works with your production dashboard, in fact. So it's a 1-liner test that you can add, and that makes sure that you run during CI/CD and make sure that your jobs still work. And there is also job migrations there. But otherwise, you need to be backwards compatible with when you create new jobs, indeed. Or what typically happens is people delete their existing jobs or create some script themselves to alter it. Yeah.
Do you really need to delete, or could we just make sure that all jobs are executed completely?
Perfect. Yeah. So if that's another option indeed. You just wait until all the jobs are. There are some people who are doing A/B deployments. So they wait with the deployment A, and it's still finishing up all the jobs, and then later on they deploy the new code, and B goes live. Yeah. No, definitely also works. No more questions? Thank you very much for your attention. Have a great conference. And enjoy the rest of the day.